Assalamualaikum student. Today we are going to discuss about Schrodinger wave equation. Here we have a combined form of Schrodinger wave equation in 3D minus h cut upon 2m del square psi. This psi is depending upon x, y, z and as well as on time, plus we have a potential energy function which is depending upon x, y, z and time, but we have also a wave function. This is a capital psi x comma y comma z comma t, which is equal to iota into h cut del psi x comma y comma z comma t upon del t dot. This is our the combined Schrodinger wave equation for 3 dimension. Okay, so if we expand this del, so we also this above equation write as del square upon del x square, del square upon del y square, del square upon del z square. Here psi x comma y comma z comma t plus v x comma y comma z comma t psi x comma y comma z comma t is equal to iota del psi upon del t x comma y comma z comma t. This is our expanded form of Schrodinger wave equation. This equation is also in 3D. If we want to write Schrodinger wave equation for 2D, so what we will do? We will neglect this term and our equation become del square upon del x square plus del square upon del y square psi x comma y comma z comma t plus v. Now here we have also x comma y comma t, x comma y comma t, because our z term is neglected because this is the Schrodinger wave equation for 2D. So psi also depends upon x comma y comma t, and here iota psi x comma y comma t. This is Schrodinger wave equation for 2D. And if we write Schrodinger equation for 1D, one dimension, so our Schrodinger wave equation in the one dimension del square upon del x square psi x comma t plus v x comma t psi x comma t is equal to iota del upon del t psi x comma t. Now if you want to separate this equation in the form of time independent Schrodinger equation and time dependent Schrodinger equation, so what we will do? We will convert this equation in the two form, time independent Schrodinger equation and time dependent Schrodinger equation, as put this wave function which depends upon x and t in the separate wave function. One is known as phi, which is spatial component, spatial function, and second say g, which is temporal function. Now put this value of psi in Schrodinger equation, so we will get minus h cut upon 2m del square upon del x square phi x gt plus v x comma t phi x gt Here we have iota del upon del t phi x gt. Now divide by phi x gt. So what we will get? We will get minus h cut upon 2m 1 upon phi x. According to condition we have to write as del square psi x plus, because this is a operator, del upon del x is operator, del x square is operator, and this is operating on a function which function is phi x. So that's the reason we not cancel out these two functions. Okay, here we have vx comma t, this both are cancel out, but we will write phi x also here. Here iota 1 upon gt. Here the answer is same as like that. This is the operator which is operating on a function and the function is gt. So now equate this equation with a term which is known as energy, because this is energy, this is energy, and this coefficient is also a energy, h cut, like energy. So if we equate this by E and this by E, so what we will get? H cut upon 2m 1 upon phi x del square psi del x square plus v 1 upon phi x is equal to E, and we will write this equation as h cut upon 2m del square phi x upon del x square plus v phi x, and this phi x we will write with E phi. So this is the Schrodinger time independent Schrodinger wave equation. So if we want to write time dependent Schrodinger equation, so we'll equate this term with E. So what we will get? Iota h cut upon gt del upon del t gt is equal to E, and we will finally write this equation as E into gt. So this is our Schrodinger time dependent equation or time dependent Schrodinger equation. So if we want to see this equation like original form, so we will put this phi x by psi x, and in this equation we will put gt by psi into t. So we will get exact shape of Schrodinger time independent equation and Schrodinger time dependent equation. So thank you for watching. In the next lecture we will discuss about the solution of this Schrodinger wave equation. Thank you so much.